Okay, for scattering, what did I say? That all the lights are coming and passing through the sample which is having minute particles. Okay, say minute particles as molecules and all. But if it is just a sample space of a room or half a room, then how much is the reduction? How much is the reduction in the blue light? Nothing, right? Nothing, right?
Yes, sir.
So if I have to replicate layers and layers of atmosphere, like as you said, 10,000 kilometers, okay, of atmosphere, if I have to replicate, or the initial 500 kilometers I have to replicate, and want to have that effect in the room, what I need to do? What do I need to do?
To increase the density of the air.
Yeah, I need to pack a lot of particles, right? Right? Get the point? So what Tyndall did is, he took a vessel and there he's putting in the smoke what he wanted to actually study. Okay? Okay? For the gas he wanted to study. Later on, or that time, I mean, he started studying with suspended particles in liquids also. So those particles are called colloids. Okay? So when I say colloids, it is a specific range of size what he studied. Okay? So say 40 nanometers to 900 nanometers diameter particles, he is mixing more and more and more. So he's kind of replicating the sky or not?
Yes, sir.
Right? Not actually. Okay, why? Because that's the big difference between Rayleigh's scattering and his scattering. He's increasing the size of the particle. Rayleigh is not saying that I need larger particles. Okay, that's a big difference between the two. Okay, get the point? But suppose, let us just go with our logic. Whatever I explained, no scattering of light, it is more of a logic of Tyndall. Get the point? And Tyndall is not actually happening in the sky being blue. So this is actually what is happening in Tyndall effect. So, but this is how Rayleigh got an idea of what is happening. So if I keep increasing the particle size, not keep increasing, sorry, if I have a certain particle size, say 100 nanometers particle, but I mix a lot of them, keep mixing, what is going to happen? The chances of blue getting hit will be more or not, right? So the blue will scatter, right? So this clear liquid starts looking like blue liquid. Get the point? This liquid starts looking like blue, and the light which comes out is now clearly having less of blue, right, and more of red, right? Right?
Yes, sir.
So if I study on the screen, that the screen is more orangish, right? Is that clear? Depending on how much you have mixed. So this is called Tyndall effect, which kicked off everything. Okay, all these studies. Is that clear? What is Tyndall effect? John Tyndall. Is that clear? Is that clear? If you increase the colloids in a suspension, your scattering will be higher. Okay? And Tyndall effect also works with the formula of 1 by lambda power 4. Meaning to say, lower the wavelength, more is the scattering, higher the wavelength, less is the scattering. But it is like this effect is, my explanation earlier is closer to this effect. Is that clear? Is that clear? Is that clear?
Yes, sir.
Okay. Okay, but it doesn't work for the minute particles. It doesn't work. This doesn't work for molecules, and hence sky blue explanation by this is wrong explanation, which is also going the round at places. Okay. In fact, if somebody watches my video initial part, he will say, okay, wrong explanation. Get the point? Get the point? Get the point?
Yes, sir.
Okay. Can I ask you a question, which is, first you'll have to do this experiment and you have to send me a video or a pic. What you do is, you take a, say, glass of water. Okay? Take glass of water, mix some atta flour. Okay, mix some atta in that. Is that clear? Glass of water is absolutely transparent. You mix some flour in it. Okay. And tell me what is the color observed of this mixture. Okay. Do it very, very carefully. Is that clear? You shine a white light from the other side. Shine white light from the other side and tell me what is the color observed over here. Is that clear, guys? Is that clear?
It will be like only like 1 teaspoon of flour.
Do it slowly, slowly. No, in your experiment, see, people did not know anything and then they figured out. We already know the theory. तो
Yes.
थोड़ा सा उनको रिस्पेक्ट देकर कुछ अपने आप से करो, कितना डालना है क्या नहीं डालना है. Get the point? Is that clear? Okay. And in fact in shops you get suspensions of various microns also. Okay, in a scientific shop I don't think you'll be able to get it easily. So with various micron size, micron means in micrometer they'll give you the size of the suspension, the colloids. You can mix and do experiment if you're damn interested. Okay. Also put a white screen on the other side and take a snapshot and tell what is the color you are seeing over here. It should come orangish, right? Right? So you have to actually prove it. Is that clear? Is that clear?
Yes.
Okay. Okay. So you can go to YouTube and look at various experiments and try out various ways of proving your Tyndall effect. Okay. Now one more thing. This is the opal. Okay, I've just taken a picture from Wikipedia. Quite interesting.
Yes.
And I want to make a point over here.
So can I?
Yeah, tell what?
So here's the when the light passes through this,
Hmm.
I think the blue light gets scattered, so we get a yellowish yellowish light on the.
Yeah, absolutely right. You're seeing that? It's not like the thing is blue. It's not like the opal is blue, but it is scattering blue. Is that clear? Something being blue and something scattering blue is two different things altogether. Are you understanding? Which is what I'll be talking in the immediately after this, which is the biggest mistake which people are making, and even some coaching places are teaching it wrong, because I was just googling and happened to see one of the reputed coaching place has given a very wrong answer to the color of the sea. But anyways, this is scattering. The point I wanted to make is this Tyndall effect? This is not Tyndall effect, by the way. Okay, this is not Tyndall effect. This opal is not having colloid or suspension like impurities. Are you getting the point? It is a pure opal and the scattering is happening by molecule. So what effect it is? What effect? What scattering is it? Rayleigh's. Okay. It is a Rayleigh scattering example over here and not a Tyndall. And as I said, we can discuss that in the next section. Is that clear, guys? So do you understand what is the difference between Rayleigh's and Tyndall? If molecules or atoms are scattering, it is Rayleigh's scattering, right? If colloid or suspended particles are scattering, it is Tyndall. Do you understand that? Do you understand that?
Yes, sir.
Okay, cool.